2007 grade 11 Hypatia math contest. The diagram shows 4 cities, A, B, C, D, with distances between them in kilometers. Penny must travel from A through each of the other cities exactly once and then back to A. An example of a route is A, B, D, C, A. List all routes that Penny could travel. So basically, Penny is going from A back to A, but then she's got to go through B, C, and D. So you just list them. Really, it's not that complicated. You can have B and then CD, or B and then DC. Or the next city could be C and then BD, C and DB. Or the next city after A could be D, then you're left with BC or CB. And then, you fill in the A's. And these are basically the only ones. So there's six possible routes. Part B, identify one route of the shortest and one route of the longest. Okay, so for example, in this route, let's count. So A to B, let's see here, A to B is 80. And then B to C is 120. And then C to D is 90. And then D to A is 40. So if you add these all up, this looks to me like 330. This one right here. And similarly, if you do the math for this guy, it is this is what, BDC, right? BDC, this is 335. This one, CBD is 325. I'll let you do all the math. It's pretty straightforward. CDB is 335. And then DBC is 325. And DCB is 330. So the shortest, I guess, would be, we'll put S for shortest. The shortest looks to me like the 325. So this one, there's an A there. This is the shortest. I'll put an S there, and this one also. And then the longest, I guess that one will put a green L. That longest is the 335s, right? So the 335s are this one, which is an L, and this one, which is an L. So you can list those as the shortest and longest. Okay, part C. Just before leaving A, Penny learns she must visit a fifth city, E. E is connected directly to each of A, B, C, D, and E is the third city that she visits. Okay, how many different routes are possible? So it's the same story, really. There really isn't much difference here. You just stick in an E here, and the rest are going to be B, C, or D. So pretty much the same thing, B, C, D, or B, D, C. If it's C, then it would be BD and DB. And if it's D, it would be BC and CB. And of course, all of these guys are E's. And of course, you got to add the A's at the first and last. And therefore, very similar to a previous part of this question, there's 6 possible routes. And therefore, we now are at the last one. Trip ADCEB, A is 600. Trip ACDEBA is 700. Distance from D to E is 225. What is the distance from C to E? Okay, so we're going to need that first diagram here. Yeah, I'm going to have to write it in. I'm just going to do a quick, like that, quick sketch. And then let's write it in. So we got C, A, B. And then now we've got a scenario where there's another city called E, and it's connected to all of the other cities. And then let's fill in the distances. 105, 120. This was 80, 40 from A to D. D is in here. 60, 90. And then C to E, they're saying, that's what we have to figure out. The D to E is 225. Okay. I think that's everything. Yeah, I think so. All right. So let's now figure it out. Okay. So this first trip, it's A to D to C to E to B to A, and they're saying this is 600. Okay, so this is 600. And then the next one, A to C to D to E to B to A. This one is 700. Okay, so I guess we can put variables. So from this route, I'll just call Y, since they're same in both. But then some of these others, they're not the same. So A to D, according to my diagram here, is 40. D to C is 90, right? Yeah, 90. And then C to E, that's what we don't know, so I'll just call that X. And in this diagram here, A to C, well, that's 105 according to my diagram. C to D, that's 90, right? Yeah. And then D to E, they told me it's 225. Okay, so that helps. 225. And then I've got a Y. So now I can create two equations from this guy. 105 plus 90 plus 225 plus Y is equal to 700. And then when you solve, you get Y is equal to 280. And then plug it back into this equation, which would be 40 plus 90 plus X plus Y is 600. And this looks like 130 plus X plus 280 is 600. So X, when you solve for this, is 190. And that is the distance from C to E, because that's what we called it up here. Olayuk has 4 pails labeled PQRS, each containing some marbles. A legal move is to take 1 marble from each of the 3 pails and put the marbles into a 4th pail. Initially, the pails contain 9915 marbles. Describe a sequence of legal moves that results in 6 marbles in each pail. All right. So here we go. So P, Q, R, S. And initially, it's 9915. Now, we've got to read this very carefully, because initially I misunderstood. I thought you were just taking 1 marble from 1 pail and putting it into another. And that's actually not true. You're taking 1 marble from each of the 3 pails. And so, for example, you would take 1 marble from P and put it in R. You would therefore also have to take 1 marble from Q and put it in R, and 1 marble from S and put it in R. So 1 marble from each of the 3 pails. That is 1 legal move. This is 1 move. So just had to kind of understand the question before proceeding. Okay, so now that we understand the question, how do we do it? Okay, so let's see here. Let's see if I can bring this to 6 marbles in each. So my ultimate goal is 6, 6, 6, 6, like that. Okay, well, let's see. I think the first move, I can put 1 marble from P to R, 1 marble from Q to R, and 1 marble from S to R. And when I do, my numbers would become 8, 8, 4, but then this guy would bump up to 4, right? Because he got 3 marbles. 1 from P, 1 from Q, and 1 from S. Okay, that's a pretty good start. Let's do it again. I think we would do the same thing. P to R, Q to R, and S to R. So that would bring this down to 7, 7, and 3. And this would move up to 7. And then finally, I guess the last one, we have to concentrate on putting marbles into S from the other three, so P, Q, and R. And that would bring this to 6, 6, 6. But then this would move up to 6, and there you go. So that is a perfectly legitimate sequence of legal moves that results in 6 marbles in each pail. Part B. Suppose that the pails initially contain 31, 27, 27, and 7. After a number of legal moves, each pail contains the same number of marbles. Describe a sequence of legal moves to obtain the same number of marbles in each pail. And explain why 8 legal moves are needed. All right, so same story, but this time we have P, Q, R, S, and we start off with 31, 27, 27, and 7. And the goal is to eventually end up with the same in each. So if we add these up, 31 plus 27 plus 27 plus 7 is 92. And if each has to have equal, 92 divided by 4 would be how many? So each would eventually have 23. Because the total number doesn't change. Just the distribution changes. All right, so let's figure this out. And this is just, fiddling around. I think a lot will have to be added to S, I think, because S only has 7 in the beginning. So, okay, so the first move, obviously, we're going to put into S from P, Q, and R. So that would make this go up to 10, and this go down to 30, 26, and 26. And then again, we're going to do the same thing from P, Q, and R, and 29, 25, 25, and 13. Well, I think we have to just do the same thing. And this would go up to 16, this would go up to 19, and this would go up to 22, right? Yeah. And these would go down 28, 27, 26, 24, 23, 22, 24, 23, 22. And then, let's see here. I think we have to keep going here. Yeah, I think we have to keep. So in one more, 25, 25, 21, and 21. Now we can concentrate on Q and R. So now we're going to put into Q from the other three. So from P, R, and S. So Q would go up by 3, 24. This would go down to 20, 24, and 24. And then finally we have to fill R from the other three, which are P, Q, and S. This would go down to 23, this would go down to 23, this would go up to 23, and this would go down to 23. So, as you can see, you just fiddle around with it, and you get your intended result. Okay, so this was part 1. There was a part 2 of this question that basically said that you need to show that you have 8 moves. Okay. Well, basically, we had to go from 31 to 23. So 31 to 23 involves 8, right? 8 moves that are needed since each move removes 1. So as we show in this part right here, you need at least 8 moves. And you can write that out in a sentence that each move results in something going down by 1. So if you want to go from 31 to 23, you have to have 8 moves, right? Because each move results in -1. So 8 negative 1s would bring it from 31 to 23. So you can write that out in a sentence. And, oh, here we go. So there's a C. Okay. Beginning again, the pails contain this time 10, 8, 11, and 7. Explain why there is no sequence of legal moves that results in an equal number of pails. All right. So this is an interesting one. So they're saying this cannot be done. Okay, so let's talk about why. So now we have P, Q, R, S, and initially we've got 10, 8, 11, and 7. And the end result, if it was possible, let's see, this is what, 18 plus 18, which is 36. So 36 divided by 4 would be 9, right? So if this was possible, it would be 9, 9, 9, 9 at the very end. And they want you to show that that's not possible. Okay, so I think the approach in this question is using parity. And in case you're not sure what parity is, parity basically just talks about whether something is even or whether something is odd, a number. I think that's what parity means. Well, if it doesn't, just forget about the word and just concentrate on even and odd. So here's the story. Every time there's a move, one of these guys will either go down by -1, right? Or will go up by +3. So if you look over here, or if you look over here, you'll see that. Like, for example, here it went from 8 to 7. So that's an example of a -1. Here, it went from 4 to 7. So that's an example of a +3. And those are the only two possible changes that any pail can have. It can either go down by -1 or it can go up by +3 because of the rules, nature of the rules of this, I guess, question. So let's talk about the different possibilities. If we have a scenario, let's say, where this goes up by +3 and these go down by -1, -1, like that, right? What is the even and odd situation? Well, this would become 13, which is odd. I'll just put O for odd. This would become 7, which is odd. This would become 10, which is even. And this would become 10, which is... Oh, sorry, this would become 6, which is even. So as you can see, here we have 4 odds, right? We have odd, 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 odd. So we are having a big problem getting 4 odds. We start off here at the very beginning. We have, let's see, odd, even. Sorry, what am I saying here? 10 is even. Jesus. So we have even, even, odd, odd, right? And then even after a move, we have this odd, odd, even, even. And you'll see no matter what you do, you always end up with 2 odds and 2 evens. And if you're not convinced, let's try again. Let's say, instead of that move, I did this move. I did a +3 here, and then the other ones were -1s. Starting with this now, with the same thing. Well, it'll go from 10 to 9, which is odd, 8 to 11, which is odd, 11 to 10, which would be even, and 7 to 6, which would be even. So again, I got 2 evens and 2 odds. And then similarly, if this was +3 and these were -1s, 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 like that, starting, of course, again with that guy, that would also give me odd, odd, even, even. And then if I said, oh, what about if I do +3 there, -1, -1, starting again with this guy, that situation would again give me odd, odd, even, even. So the point I'm trying to make is that no matter what you do, you will never be able to have 4 odds. And you can explain that with more examples, and hopefully, you'll be able to make a convincing argument that indeed there is no sequence of legal moves that can result in an equal number of marbles in each pail if you start with those numbers right there. Consider the quadratic function f at x is equal to x squared minus 4x minus 21. Determine all values of x for which f at x is 0. So 0 is equal to x squared minus 4x minus 21. And we factor x, 7, and 3, I believe minus and plus, right? So therefore x is either 7 or -3. And that's it for part A. Part B, if s and t are different real numbers such that s squared minus 4s minus 21 is equal to t squared minus 4t minus 21, determine the possible values of s plus t. So s squared minus 4s minus 21 is equal to t squared minus 4t minus 21. Put everything on one side, and we get s squared minus t squared minus 4s plus 4t is equal to 0. Let's do some factoring here. SSTT minus plus minus 4s minus t. Okay, I think that is correct. All right, let's factor out the minus s minus t, and I get s plus t minus 4 is equal to 0. All right. That's about as far as I can go. So this means that either s minus t is 0, or it means that s plus t minus 4 is equal to 0. If that's true, that means that t would be equal to s, but that's not possible because these are different numbers. So this is not admissible. So this is the only solution, so that would mean s plus t is equal to 4, and that's exactly what they are asking. So 4 is the answer to this question. It's the only solution, and this is not possible because s and t are different according to the question. So this is the only solution. Okay, part C. If a and b are different, again, positive integers, such that a squared minus 4a minus 21 minus b squared minus 4b minus 21 is 4, determine all possible values of a and b. Now, explain how you got your answer. Okay. So I have this time a squared minus 4a minus 21, and then I've got to subtract this b squared minus 4b minus 21, and that is equal to 4. And then I've got to come up with integer solutions, right? Because they're both positive integers. So not only are they integers, but they're positive. So that is my criteria, positive integer solutions to that equation. Okay, so let's expand it and see what we can do. Minus 4a plus 4b, and I believe the 21s cancel. Yeah, minus 21 plus 21, yeah. And then I've got this 4. Let's just keep that 4 on the other side. And let's factor this. So I got a, b, minus plus, minus 4, a, and b, minus, I believe. So then I guess an a minus b can be factored from both, and then that would give me a plus b minus 4 is equal to 4. Okay, so it's not, this number is not 0 this time, it's 4, but that's okay. We can still do it. Let's make a little table. A minus b, this guy, and then a plus b minus 4, which is this guy. And when you multiply them together, they've got to equal 4. So therefore, we then have to solve for a and b. So what are my possibilities? Well, I could have 1 and 4. I could have 2 and 2. Or I could have 4 and 1. But don't forget the negatives. Negative 1, negative 4, that would also work. Negative 2, or negative 4 and negative 1. Okay, so you just have to solve for these. So for example, let's look at the first one. If a minus b is equal to negative 1, and a plus b minus 4 is equal to 4, if you add these, 2a minus 4 is equal to 3. So 2a is, wait, hold on. Did I do this correctly? So sorry. Oh, a minus b is equal to 1, positive 1. Sorry about that. So this is going to be 5 actually. So 2a is 9, therefore a is equal to 9 over 2. Well, 9 over 2 is not it's not an integer, so that's not a solution. In the same way, I'll just do one more. Let's do the second one. A minus b this time is 2. A plus b minus 4 is 2. So if you add these guys, what do I get here? 2a is equal to 8, and therefore a is 4. Yeah. And if you solve for b, b would be 2. Yeah. So this is an integer solution right here. And similarly, when you do the other guys, this will be 9 over 2, so that won't give you anything. This will be negative a half. That won't give you anything. This will give you 0 and 2, which initially sounds like an integer solution, but remember that a and b have to be positive integers, and 0 is not a positive number. So that one's no good. And this is negative a half. So interestingly, the only integer solution to this question is 4, 2. In the diagram, 4 circles of radius 1 with centers PQ, RS are tangent to one another and to the sides of triangle ABC as shown. Determine the size of each of the angles of PQS. PQS, okay. So the first thing, of course, is I'm going to have to draw those lines. So let's draw them carefully. P to Q. And then we got another one, right, from Q to S. And then finally, one more from P to S. Okay, so that's the triangle, right? Angles of PQS. All right. So let's see what I can do here. Well, I'm gonna have to put in a lot more, but my fear is that it's gonna be that it's gonna make this diagram messy. But I think I can do it without making it too messy. Let me just draw in one more line from P to R. And then what I'll do, I'll just draw it on the side here. So I've got this triangle here like this. Yeah, it's basically like that, right? So we have P, Q, R, S. Now, if you look at this diagram carefully, the length from P to S is 2, right? Because it's just 2 radii. This is 1 and this is 1. And they told me that all the circles have a radius of 1. And very similarly, P to R is also 2 and R to S is also 2. So that's an equilateral triangle, P, R, and S. They're all equilateral. Well, they're all the same side, so it's equilateral. So that means these are 60 degrees. That's the first finding. And then I noticed that this would be 120, right? Just from complementary angles or whatever you want to call them. And then, therefore, since R to Q is also 1, 1, this is isosceles, this PQR. So therefore, these angles in here would be the same. So if that angle is 120, then those angles would add up to 60, and since they're the same, they would be 30 each. So basically, I've got a situation where I've got a 30, 60, 90 triangle. And I think that's what they want. They just want the size of each angles, right? So it's basically, if you want to draw it again, this is 90, this is 60, and this is 30. And that is P, Q, and S. So I think that's all they wanted for part A. Part B, determine the length of each side of ABC. Okay. Well, that's where our fundamental rule comes in, which hopefully you know by now, that in the 30, 60, 90 triangle, the ratio of the sides are 2, 1, and root 3. So since ABC, the big guy, is similar to PQS, right? Because these are perpendicular lines. If you look like P to Q is perpendicular, and so is P to S perpendicular to AC, and Q to S is perpendicular to BC. So those are similar triangles. So triangle ABC is similar to triangle PQS. You got it? So I think that's pretty much all we have to do. Yeah, is just first figure out the angles, the length of one, and then we can compare it to the other. So first, let's just concentrate on the PQS. Yeah, the PQS. So that side, Q to S, is 4 in terms of its actual side length. And you can see that in this diagram here, right? Because you had a 1, 1, 1, 1. So they're 4. You notice that side is 4. And then P to S is 2, again, from this diagram. And then P to S, P to Q. Even if you don't know it, you can just use the ratio. It would be 2 root 3, right? Yeah, 2 root 3. Just from the fact that the ratio of the sides. Now, ABC is also a 30, 60, 90 triangle. So it would be very similar. So there's lots of ways of doing this, but I think I'll just do a comparison way, which is as follows. What I'll do is I'll draw a perpendicular right there. That's a tangent. And then I will try to figure it out that way, and then draw one more tangent here. And I'll draw one final line from S to C, like that. And that will allow me to figure this out. Okay, so from here to here, from A to this point right here, which I can just call it whatever, let's just call it T. That's going to be 3, because it's just 3 radii. Yeah, it's 3 radii, because if you extend P, you'll notice it's like another radii. So that's 3. And then now I want to figure out from T to C, this guy right here, what is that? T to C. Okay, so T to C, what I'll do is I'll just draw that triangle over here, avoid making the diagram too messy. So we have T, and then we have S, and then we have C. And this is a right angle. And then this angle in here was 60, right? Yeah, because it's the same as this angle, since those triangles are similar. So if that's the case, then this little guy would be 30, since it's half, and then therefore this is 60. So again, we have a 30, 60, 90 triangle. And the ratio of the sides again are 2, 1, and root 3. And since we know that this is 1 in terms of its actual length, this actual length is 1, this actual length is 2, and this actual length is root 3. So therefore, T to C is root 3. So therefore, AC is 3 plus root 3. And then BC, remember the ratio of the sides again for the 50 millionth time, 2, 1, and root 3. So BC would be twice that. So it would be twice of AC. So there would be 6 plus 2 root 3. And then finally, AB is basically root 3 times AC. So 3 plus root 3. So that would give me 3 root 3 plus 3. And I believe that completes that question. And then finally, we have part C, which says that the radius of the circle with center R is decreased so that the circle with center R remains tangent to BC, the circle with center R remains tangent to the other 3 circles, and the circle with center P becomes tangent to the other 3 circles. This changes the size and shape of triangle ABC. Determine R, the new radius of the circle with center R. All right, so my task here is to come up with a diagram. All right. And here is that diagram. So as you can see, as they said in the question, when this circle is decreased in size like that, it changes the shape of ABC to triangle. Okay, so how do we proceed with this question? Well, we are going to have to break it up into a few sections, and I'll draw that on the diagram. The first thing I'm going to do is draw a line directly from Q all the way to to S, I should say. And then I will draw a couple more lines. Hopefully it will help us. Q to R, and then R to S. And I think that should be good enough. Maybe one more line might help. A all the way down to the bottom like that. Okay, I think that should be good enough, but if we need more lines, we can always add them later. Okay, and then everything's labeled already, but there's one more, this point right here. I'm going to label that guy. This guy, I'll label it Y. Yeah, that's this point right here. The point right in the middle of QS, that line. Okay, so now we have to kind of analyze this a little bit. I'll draw it on the side here to avoid confusion. I'll draw this triangle, this Q, Y, and R triangle. That now from Q to R, that is just the 2 radii. From Q to this point is 1, and then from this point right here to that big R is the radius. So that's going to be 1 plus R. And I hope you're convinced of that. And then what else can I do here? from y to r is interesting because y to r is going to be, I believe, 1 minus r, but I'm going to have to illustrate how I got that. So I'm going to have to draw one more line from q down to the bottom here. So, for example, q down to the bottom is the same as y down to the bottom, right? And that's 1. But then r down to the bottom is small r. So y to r would be this 1 minus that r. So I hope that made sense. I'll write it out here. This 1 minus this r would give me this y to r. And that's a right triangle. And I think that's about as far as I can get. QY, I'm not sure yet. But I can use Pythagoras in this triangle. This triangle QYR, that QY squared plus YR squared is equal to QR squared. So that means that QY squared will be QR squared minus YR squared. So QR squared, we know, is 1 plus R all squared. And then YR is 1 minus R all squared. So we got some math here to do. So we got 1 plus 2R plus R squared. And then we have minus 1 minus 2R plus R squared. And therefore, it's going to be 4R. Yeah, because everything else cancels. Okay, that's a pretty good result, I think. That's QY squared, okay. Okay, so that's actually QY squared. So it's not QY. All right, so that's a pretty good result. Now, we are trying to figure out what? The actual value of R, right? Okay. So I'm going to have to look at some other triangle here. I guess I'll look at this triangle here. This one right here. This one, PQY. I think that triangle should allow me to solve this triangle PQY. Okay, let's see what kind of relationship I can get there. That's also a right triangle. So PY squared plus QY squared is equal to PQ squared. And let's see, PY. Well, PY is the equivalent of P to R minus YR, correct? So P to R is what? 1 plus R, correct? Yeah. And then YR we had somewhere. Yeah, it's right here, 1 minus R. So this looks to me like 2R. Okay, that's good. So I can put that in there, 2R squared. And then QY squared, I think I just got right here, so that's 4R. And then PQ, P to Q. Well, those are just 2 radii, so that's just 2. Is that it? Yeah, I think so. Okay, great. So I have an equation I can solve for R. So this will be 4R squared plus 4R minus 4 is equal to 0. Divide through by 4 and get R squared plus R minus 1 is equal to 0. I think we're going to have to use a quadratic, so R is equal to minus B plus or minus the square root of B squared minus 4AC, negative 1 in there, all over 2 times 1. So negative 1 plus or minus, what is that, 1 plus 4, so root 5 over 2. So of these, the only option is the negative 1 plus root 5 over 2, because radius obviously cannot be negative. And I think that's it. So we have solved for R, and that completes this question.